Understanding and calculating confidence intervals for proportions. Hi, I'm Dr. Nick from Creative Maths, including Statistics Learning Centre. In this video, I'm going to explain what confidence intervals for proportions tell us, how to calculate them, what the effect of different confidence levels is, and some important things to remember when reporting confidence intervals. To find out about confidence intervals in general, watch our video Understanding Confidence Intervals. There are two main types of data, categorical and measurement. With measurement data, we usually summarise using the mean or median, with a confidence interval giving an estimate of the range within which we are pretty sure that that population parameter lies. With categorical data, we summarise by giving the proportions of responses or outcomes for each of the possible values. It is quite common to see confidence intervals given for proportions for political polls. We cannot usually ask the entire population their opinion on a certain matter or who they would vote for. So we ask a sample of the people and draw conclusions about the population from that sample. We use a confidence interval to report the range within which we are pretty sure that the population parameter lies. Here is an example. We are exploring the idea of a dessert takeaway restaurant, and we're interested to know people's habits around fast food. We ask a sample of 153 people in New Zealand what their favourite takeaway food is. Out of them, 20 say fish and chips. The sample proportion is 20 divided by 153, which gives us 0.13 or 13%. We calculate the confidence interval for the population proportion using this formula. The standard error in this instance is the square root of 0.13 times 0.87 divided by 153, which comes to 0.027. This standard error is multiplied by the z value, which in this case is 1.96, to get the margin of error. The margin of error is 1.96 times 0.027, which equals 0.0529. This margin of error is added to and subtracted from the sample proportion to get a confidence interval of 0.077 to 0.183. We can be 95% confident that between 8% and 18% of people in the population like fish and chips the best. This is a pretty big interval, but that is because we had quite a small sample. When samples are bigger, the width of the confidence interval reduces. If we wish to be more certain to have the true population value within our confidence interval, we will need to increase the stated confidence level. This changes the z value that we use. You can see in this table that as we increase our confidence level from 90 to 95 to 99%, the width of the confidence interval increases. The more confident we wish to be, the larger our confidence interval will be. There are two conditions we need to test for to make sure that it is valid to use this formula. We need to make sure that we're not testing more than 10% of the population, and the following must hold. NP is greater than 10 and N1 minus P is greater than 10. This is because the formula works on the assumption that the sampling distribution of the proportion is well modelled by the normal distribution. The sample size of 153 is considerably less than 10% of the adult population of New Zealand, so we're fine there. NP equals 20 and N1 minus P equals 133. Both of these values are greater than 10, so we are fine there as well. Important things to remember. This confidence interval gives us a range of values that we can be pretty sure or confident contains the proportion of the population. It is quite possible that this interval will not contain the population proportion, but usually a confidence interval will contain the population parameter we are estimating. When we report a confidence interval, we must be careful to say that the confidence interval is about the population proportion. We know what the sample proportion is, so we do not need to make a confidence interval about it. If you would like to know more, please ask questions in the comments below or on the channel community chat. Do click on like and subscribe to the channel, and may your confidence intervals be small.